All right, calculus class. This is the first problem from Monday night's homework, March 30th. It's the one with the rate of change of the people standing in line. As we go through these, we're going to do a lot of problems like this. At the beginning they might be a little tricky, but they all are very, very similar. So you'll see the more you do, the better you'll get at them. It won't be too bad. Anyway, we had this little model. At certain times, how many people were in line. The first question says, use the data in the table to estimate the rate at which the number of people waiting in line was changing at 5:30. T equals 5.5. This problem pops up a lot. It seems a little bit weird. The rate at which they're changing is the slope, which is derivative. So I want the slope at 5.5. I drew a little picture there. What they're looking for is that slope. The problem is I don't have an equation. So I can't just take the derivative, plug in 5.5 and be done with it. So the best I can do is approximate. And I approximate based on the best numbers I have in the chart. So if I just use my point here at 4 and my point here at 7, draw that line, it's the best I can do, right? So these other points aren't going to mean anything. That's the closest approximation I can get using these numbers. So I'm just trying to find the slope of that green line. So the slope of that green line is L at 7 minus L at 4. It's the 150 minus the 126 over the 7 minus 4 over the 3. As I was looking at the homework that's been turned in so far, most of you guys got this. But it's a little bit weird to know what to do this the first time. So it's 8 people per hour. Don't forget about units when they ask. I'm going to give you the grading on this. Every FRQ is worth 9 points. So if you were grading this on your own, this would be worth 2 points. It'd be 1 point for just getting the basic idea, and then 1 point for pulling it off. So if you happen to get the wrong answer because you used the wrong numbers or something, it'd still give you a point for the work. Second question says, use a trapezoidal sum with 3 subintervals to estimate the average number of people waiting in line during the first 4 hours. So I'm going to kind of walk you through this one, actually do it. So first things first, average number. If you're in a calculus class and you hear the word average, you should probably be thinking integral. So remember we have a formula. The average value of any function is just the integral of that function divided by the length of the integral. So for this particular problem, they asked me to find the average from the first 4 hours, 0 to 4. So divide that by 4. So I need to find the integral. Integral is just area under the curve. But I don't have an equation, right? But I have a picture, so I can do a trapezoidal rule. I'm going to use my numbers here so I don't botch up the numbers on you here. But it's a trapezoidal rule with 3 subintervals, so rectangle 1, rectangle 2, rectangle 3. We're going from 0 to 4. Okay? Trapezoidal rule is the average of the left and the right. So this first rectangle has a width of 1 and a height of, if we're using the left-hand rectangle rule, it's that height, which is the 120. Second rectangle has a width of 3. And for the left-hand rectangle rule, we're using that as the height, which is the 156. And the third rectangle has another width of 1. And left-hand rectangle rule, the height at 3 is the 176. According to my numbers here, I'm just going to copy these down so I don't mess them up, 608. The right-hand rectangle rule, the widths are the same, so 1, but instead of using the 120, I'm now going to use the 156. Width is still 3, but instead of using the 156, I'm going to use the 176. And the last one, same width as 1, but instead of using the 176, I'm going to use the 126. Those numbers added up to 634. The average of 608 and 634 was 621. So 608 plus 634 divided by 2 is 621. 621 is the area under the curve. So I'm going to take that and divide it by 4. So the average number of people waiting in line is 155 and 1/4 people. That's the average number of people waiting in line. This problem was worth 2 points. Again, 1 for knowing the trapezoidal rule and pulling it, 2 points. So it's 1 for this, for knowing this, and then 1 for doing the trapezoidal rule right. All right, we flip this over for the Last two parts. Part C. Find the fewest number of times at which the derivative must be equal to 0 and then give an answer. So I haven't quite done it yet, I'm just going to walk you through it. The derivative equaling 0 means the slope of the tangent line has to be 0, which means it has to be a turning point, right? So we're basically looking for turning points. So I just do a pretty rough picture just like I did the other one. You can also get it from the chart when you're going up, down, increasing, decreasing, increasing, 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 decreasing, increasing, so you can see the turning points, right? So we got 1, we got 2, we got 3. So what you would need to say is 3, and then you would want to say something about turning points or min-max. But remember that in order for this to work, your graph must be continuous and differentiable. You must use that wording. They tell you that it's differentiable in the original problem. And remember that if it's differentiable, that implies that it's continuous. So you just have to say, because the graph is continuous and differentiable, there'll be 3 because there's 3 turning points as shown in your picture. Or because it's going from increasing to decreasing to increasing to decreasing. You can use that wording also. Points on that one. 2 points. 1 for the right answer and 1 for some sort of good explanation. And the last problem, for some reason, is worth 3 whopping points. It's really the easiest problem of the whole thing. The question was, here you now have a model. That's the rate, and find the total number of tickets sold. So remember, if you have a rate, and you want to find the total of whatever you're doing, you just integrate. So we're integrating from 0 to 3. I just dumped that on my calculator. It's a straight calculator problem. I've got 972.78 or 973 tickets. 3 points. It's 1 for getting that integral right, showing the numbers and showing what you're putting in your calculator. 2 for getting the right number, and 3 for the units, believe it or not. Whenever there's units in a problem, it's very, very important to get them on there. So that's the first problem from last night's homework. The second one will be on another video.